Welcome to the Lionheart Academy. Today we're continuing our trigonometry lesson. Today is the lesson number 15. We're talking about functions of any angles. So last lesson we already talked about the definition of how to define trigonometry functions for any angles based on the coordinate plane, okay, from 0 degree to 360 degrees and more. Now today we have a few things we have to mention on top of that. One of the most important thing is the signs of the functions in each quadrant. Now, as we talked about last time, okay, depending on which quadrant you are in, you're going to affect the signs of your quadrant, your functions. Now, why is that? Okay, well, in quadrant 1, let's go ahead and label the quadrants again. Quadrant 1, quadrant 2, and then we'll take a look at why that is. Quadrant 3 and quadrant 4. Alright, so in quadrant 1, any point in quadrant 1 would have a positive and positive coordinate. So their x coordinate would be positive and their y coordinate would be positive. And the radius, now if I go ahead and draw a radius here, okay, the radius also will always be positive. So that's one thing that you have to remember. The radius always will be positive. So if I have a point P here, and then with x and y coordinate, r will always be positive because r is the distance from the center to the terminal point here, to the point here on this terminal side. And x, y can be different signs, but in quadrant 1 it will be positive. So that means that all the sine functions, all the sine, tangent, cosine, and tangent, they all of them will be positive in quadrant 1. Okay, so let me go ahead and erase that. So sine will be positive, cosine will be positive, tangent also will be positive. Secant will be positive, cosecant will be positive, and cotangent also will be positive. So all 6 functions will be positive in quadrant 1. The reason is because both x and y are positive and r is positive, so all their ratios. Okay, now let me go ahead and remember this. So sine is x is y over r, and I'm jumping the gun a little bit. Sine of theta, cosine of theta is x over r, okay, and tangent of theta is y over x. Alright, secant of theta will be equal to r over x, and cosecant of theta is r over y, okay, and cotangent theta is x divided by y. Alright, so based on this information, the definition that we used last week, we can see that all of them will be positive if x and y are positive. So r is always positive. Now in quadrant 2 though, the point x coordinate will become negative because it becomes in the negative part of the x-axis. However, y remains positive. So that means sine is still positive because y over r is positive, okay, but cosine is negative. Cosine will become negative. Tangent will also become negative because x is negative, so positive divided by negative is negative. Secant will be negative, and cosecant is positive, and cotangent is negative. So as you can see, only sine and cosecant are positive in quadrant 2. In quadrant 3, both x and y becomes negative. Okay, both x and y become negative. So sine becomes negative, cosine is negative. However, this time tangent is positive because you have negative divided by negative is positive. So secant is negative, cosecant is negative, but cotangent is positive. So as you can see, only tangent and cotangent are positive in quadrant 3. In quadrant 4, x is positive, but y is negative. So sine is negative, cosine is positive, tangent is negative, excuse me, secant is positive, cosecant is negative, and cotangent is also negative. Okay, so there is an acronym that we can use to help us remember things. Okay, so let me try to write you an acronym. It's ASTC. So it's all student takes calculus. All students take calculus. All means everybody is positive in quadrant 1. S means sine, and its reciprocal cosecant is positive. T means tangent, and tangent and its reciprocal is positive. And C is cosine, and its reciprocal secant is positive. So ASTC. So that's how you remember All functions positive in quadrant 1, sine and its reciprocal is quadrant 2, positive in quadrant 2, tangent and its reciprocal is positive in quadrant 3, cosine and its reciprocal is positive in quadrant 4. Alright, so that will help us really to throw things out. So what do we use with this information? Well, then we can go ahead and do some kind of problem. We can do some problems where we have some information about the angle, but we don't know. Let's say we know sine of the angle is 3/5 or -3/5. So how do we figure out the rest of the function? Which quadrant could they be? Okay, so let's take a look at those kind of examples. Okay, so now we have an example here. It says, given sine theta is -3/5, find the values of the other functions. Alright, so first of all, let's go ahead and think about this. What quadrant could this angle be in? Well, let's go ahead and draw a diagram here. So first of all, it says the sine of the angle is -3/5. Now, if I remember ASTC, right? So that means it's not going to be in quadrant 1, it's not going to be in quadrant 2, because AS, right? So everybody, ASTC, again, acronyms ASTC, all is positive, sine is positive, so it's not going to be in first two quadrant. So it will be in the third quadrant, or it's going to be in the fourth quadrant. Okay, now so what does the -3/5 mean? Okay, well, in the sine is the opposite. Remember, it's called the opposite over the adjacent, right? Remember, opposite over adjacent, or is y over r. So y must be equal to a negative value in those two quadrants. Is that true? So y in this case must be equal to -3. Because r is always positive, so r will be 5 here, and r will be 5 here. Okay, and so y will be equal to -3. So as you can see, these two angles now it could be coming. Let me go ahead and draw it. It could be coming this angle, or it could be coming through this angle. Okay, so both of those angles have the same sine values. They have the same sine values now, but you can see their x value is different, right? So for the angle in quadrant 3, the x could be a negative number, and then x is called x1, and then for the angle in for theta 2, let's call this theta 2, okay, and let's call this theta 1 here. So theta 1 is the one in third quadrant, theta 2 is the one in fourth quadrant. But here, as you can see, they have different x values. Now they actually have this this x1 is negative, this one x2 should be positive. So we got to go ahead and solve for that. Okay, now what was our relationship between x and y and r? It's the Pythagorean theorem. X squared plus y squared is equal to r squared. So we don't know what x is. Well, we go ahead and plug in -3 here, equal to 5 squared. So x squared plus 9 is equal to 25. So x squared equal to 16. 25 minus 9 is 16. So x equal to plus minus 4. Okay, so that tells us that, oh, okay, so x1 is going to be -4, and x2 is going to be equal to positive 4, because this side is in this side is in the positive x-axis, this side is on the negative x-axis. So we got x equal to plus minus 4. Alright, so that means we can go ahead and solve for both angles, whether they're in quadrant 2 or quadrant 3, doesn't really matter. Okay, so let's go ahead and do that. Alright, so in quadrant 3, let's do in Q3, the sine of the theta will be in -3/5, right? The cosine of theta will be a -4/5, because it's x over r. Tangent of the theta will be a positive 3/4. Okay, opposite over adjacent, or y over x. Okay, secant of the theta will be -5 divided by 4. It's the reciprocal of cosine. Cosecant of theta will be -5 divided by 3. It's reciprocal of sine. And cotangent of theta will be 4 divided by 3. Adjacent over opposite, or x over y, or it's the reciprocal of tangent. So there are several ways we can look at this. Now, if theta is in quadrant 4, the sine of theta is still a negative 3/5. So this is going to be a very important thing because it connects several angles. They have the same sine, but they have everything else would be different. So the cosine will be actually positive 4/5, and tangent in this case would be y over x is negative 3/4. Okay, secant of theta will be the reciprocal of cosine, so it's 5/4 positive, and cosecant theta will be a negative 5/3. As they're the same because they're the reciprocal of sine, and cotangent of theta will be a negative 4 divided by 3. Okay, it's the reciprocal of tangent, or is x over y. X is 4, y is negative 3. Alright, so let's try another example like this. Alright, actually this example number 2 is a little bit different. It says given tangent theta is negative 5/12 and cosine theta is negative, find all functions of theta. So we actually have two conditions here. Okay, so let's go ahead and figure out which quadrant is this angle theta should be in. Okay, it says tangent theta is negative 5/12, so tangent is negative. Now remember ASTC, right? So if tangent is negative, it can be in what? Quadrant 2 or in quadrant 4. But cosine is negative, so which other quadrant is cosine negative? Well, cosine is negative in second quadrant because it's ASTC. In fourth quadrant, cosine is positive. So this angle has to be in quadrant 2 because quadrant 2, both sine and cosine is negative. No, I'm sorry, both tangent and cosine is negative. Okay. Now, how do I label this this point here, or how do I label this right triangle information based on tangent theta is negative 5/12? Now you see tangent is the y over y over x, right? Y over x. So it's negative 5/12. Now y cannot be negative here because y is positive. So y should be equal to 5, and then x should be equal to a negative 12. So your x value in this case is negative 12 and y is equal to 5. So the only thing we do not have is r. Okay, so let's go ahead and find r for this angle theta. Alright, this angle theta can be, if we count from positive, it will be this angle. So how do we find that? Well, we use the Pythagorean theorem again. X squared plus y squared equal to r squared. So it's negative 12 squared plus 5 squared equal to r squared. So that's 144 plus 25 equal to r squared. So r squared is 169, and that means r is equal to 13. Now again, r cannot be negative because r is radius. Radius is a distance. It's a positive distance. It will never be negative. So r is 13 here. Alright, then we can go ahead and find sine of the theta. Sine of theta is y over r, so it's 5/13. Cosine of theta is x over r, so it's negative 12 divided by 13. And tangent of theta is, we already know that, it's given to us, negative 5/12. Okay. Secant of theta is the reciprocal of cosine, or is r over x, so 13 divided by negative 12. Okay, cosecant of theta is reciprocal of sine, or 13 divided by y, r divided by y, 13 divided by 5. And cotangent theta is reciprocal of tangent, is negative 12 divided by 5, or is x over y. Okay, so this is how we can go ahead and identify the situation here. Alright, so hopefully this will give you a good idea of the signs, and then how each function is related, how their signs related, why they are negative, why they are positive. And we have definitely a lot of exercise that you guys can practice. I'm going to post that online and just show you the link to the practice pages. And then if you have any other questions, please leave a comment, and then we hopefully will see you next time.